Well, hello everybody. It's time for yet another lesson in Python programming. We're going to go through the basics. We're going to go a little bit further than we've gone so far. I've noticed that in the past, a lot of students apparently have not paid a lot of attention to this second tutorial, but in reality, there's far more in the second tutorial that's important. And I'm going to emphasize that in an email to you all. You need to watch this one because this contains really the important commands that you'll be using in your first program. There are more. There will be another tutorial in the second week or so, maybe even the third, where I talk about some specifics that will add to program 2 and program 3 that you're really going to need to know. So anyway, I hope you're paying attention. You're taking notes. You're looking at you're printing up the slide deck and writing notes on it. This slide deck is still my copyrighted information. So don't distribute it, but certainly you can take notes on it. So let's move on to the desktop and let's see what we got here. Now we're going to be bouncing back and forth, and occasionally I'm going to misstep on that. I just know I will, but hopefully you'll bear with me. I'm not completely perfect at doing these things yet, but let's go ahead and go through the tutorial. So title slide, yay, next. So this is what we're going to be talking about. First of all, I decided, on thinking about it, I decided to show you yet another way that you can use Python. I told you a lot of options and everything, and there'll be an email on this, or there'll be not an email, but there'll be a news item on this at the start of the week that talks about what your options are as far as getting basic Python, a Python interpreter installed or available to you. Previously I showed you Replit, and I told you I wasn't going to show you Replit again because I think its limitations. It's actually a very good interpreter. I don't have any problems with that, but the fact that you'd have to pay for it most likely kind of outweighs the advantages of it being online. So I'm going to show you probably one of the simplest and most cost effective, because it costs nothing, programs to install that will allow you to do Python programming. And that's the one that's provided by the Python Software Foundation itself. So, that is going to be called the idle development environment. It's not a very robust development environment, but it is sufficient for what you need for this class. And it's very simple to install and relatively simple to use. It doesn't provide, later on, probably in the second class, I'll start using Microsoft's Visual Studio Community Edition, which is also free, but it is much more complex because it's intended for people that, while they may not be professional programmers, aspire to be professional programmers. And so it has a ton of the literal bells and whistles that that makes it harder to really understand and use the development environment. But once you do, it's got a lot of value. Don't get me wrong. So if you're already in programming classes and you're using Visual Studio Community Edition, continue to do so. But for those of you that are still unsure as to your commitment to being a professional programmer, well, you might put that off till we get through this class, and maybe you go on to another class where you're going to be focused on programming the entire time, at which point you're going to want to have a good development environment like Microsoft Visual Studio 2022 is the version I'm using. There's probably a 24 out there. I haven't looked recently, but Visual Studio 2022 Community Edition. There's a Visual Studio that you pay for, and it's expensive too. It's quite a bit, but the Visual Studio Community Edition is kind of basically just an older version of Visual Studio. It's not very old either. So I'm assuming that when Visual Studio 2024 comes out, or 2025, whatever is the next version, the commercial version, that there'll be a similar update to Visual Studio 2020 Community Edition, and so it's probably going to have all the features and functions in Visual Studio, whatever that Visual Studio Community Edition, whatever that future edition happens to be. It'll probably have all of the features and functions of Visual Studio 2022. So the big difference is community just means it's free, it's available. You can download it, you can install it. It takes a lot of space. Like I said, it's complex, but you're probably not going to want to do that. Then we're going to go through these other things: values, types, variables, and expressions, reserved words, statements, operators, expressions, comments, casting, input, output, and conclusion. There are other things that we will cover in other tutorials later, and there's a whole bunch that we're never going to cover. So, but this is enough to get you through the first 3 programs and give you a real taste for what programming is like. So let's move on to the next slide. So we're going to talk about the idle development environment. And again, that environment is owned by the Python Software Foundation. So when Guido managed the development and owned the original copyright up until version 2.0 in the early 2000s. And at that point, he wanted to kind of move on to bigger and better things. He gave up his title as benevolent dictator for life. And he created the Python Software Foundation as a nonprofit organization. The link is there, so we're going to go ahead and I'm going to go ahead and show you what that looks like, real quick. So again, just a moment. Give me a moment to get there, and yeah, I got it. So this is what it looks like. I'll go ahead and expand that so we don't have the distraction of the slide behind it. This is what it looks like. There's a lot there. You can see. I'm not going to read through it, but there's a ton of stuff there. And if you really get interested in Python, absolutely suggest that you spend time here. To get Python downloaded on your machine, you just go to Downloads, and you can go to Downloads and then select from there where you're going to go, or you can just simply go to, in my case, it's Windows, and here's the latest. It's going to show you the latest Python 3 release, which is 3.13.1. However, I would always go to the stable Python, stable release. This means, in all probability, 3.13.1, which is the version number, probably is still either alpha or what we call alpha or beta. It's being put out there to the community to test, but it's not fully baked yet. There still might be problems, and they put it out there for adventurous people to play with and see if they can break it, and then they take that information, they try to fix it before they actually get to a stable release. If they have it out there for a long enough period of time and they're not getting any real crazy bad stuff happening, then they will name it as a stable release, and it'll be here at the top. In this case, there's a number of installers that you can use for Windows. You can also do it, it'll also run on Mac OS. I think if we go back to downloads, I had gone to Windows, if I remember rightly. Downloads, Windows, Mac OS. There are other platforms like Python for AIX, which is IBM's flavor of Unix, AS400, iSeries, or iSeries. It's historically been known as the AS400. It was that way for many years, and then somewhere, I think in early 2000s, as I recall, or late 1990s, marketing got a hold of it and decided that no, iSeries would be better. Actually, it was early 2000s because they renamed their standard AIX boxes, P series, and the mainframes were Z series. So, and then we have Python for iOS, which is still, that's another old version of the Mac OS. Python for ZOS, this is mainframe, and Python for RISC, which is that was an offshoot of Unix. Python for Solaris was Sun's operating systems, which is now owned by Oracle, and blah 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 blah. So HPUX, which is another flavor of Unix for Hewlett Packard machines, and blah 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 blah. So there's lots of things out there. In reality, for all of us here, you're going to probably stay with you're going to either be looking for Windows most likely, or you're going to be looking for Mac OS. So let's go back there. Again, click on this link. It'll download an installer to your downloads directory, and go into the downloads directory, click on it. It is a very straightforward install. Just take the basic options and let it install. So what does it look like once it's installed? Well, let's go out there and find out what that looks like. Well, first of all, let's let me show you this, and then so this is just a regular command prompt. For those of you who have Windows machines, this is how you enter a command in. It's just an application you open up in Windows, and then all I'm going to do is type Python. And notice that what happens is this opens what we call as a shell. Now this is different than the development environment. I'm going to show you the development environment in a little bit. But you can do things in you can enter commands. This is direct hotline, if you will, to the interpreter. So we're going to say print. We'll do print. Hello. You already saw me do this once. Hello world. And we're going to hit enter, and it does it. Okay. That's, and for messing around with something, it's fine. However, it's not a really helpful, it's not a very helpful development environment because, well, what if I want to save this? Well, I could cut and paste the commands into a file. What if I wanted to run a file? Well, there are command line arguments that there are command line arguments. Probably this Python -h. There's command line arguments. So it's possible, my guess is that somewhere in here there's a command line argument that says open a file and run it. Okay. So you could just simply use a shell. However, the IDE Integrated Development Environment, which is called IDLE, IDELE, is a little bit better. So we'll go ahead and I'll open that up for you here just a moment, and we'll bring that up. Let's see, where do I want to go? There, and I know you're not seeing this, but that's fine. You don't need to. Okay, it's just showing where my. Let me bring this over so you can see it. This is the idle development environment. Well, it's a little bit better. We can still do print hello world, but notice that we're getting more information. However, and it operates like a shell. However, you can do things like you can edit, you can open a file, you can create a new file, and you can just, in that file, it pulls up Notepad, but you can set it up to open up any editor you prefer. I wouldn't suggest using something like Word. I would always use a text editor like Notepad, simply because Word puts all sorts of characters behind the scenes that you don't see to do formatting and things like that. For those of you done any web programming, it'd be something like HTML or XML or something along those lines, in order to provide formatting commands that, as far as being able to type, you don't really want to see all that junk. What you want to do is, you don't want to see it, but you want the impact. So if I wanted to change the font, or I wanted to use the thesaurus or whatever it was, or I wanted to do references, I wanted to create hyperlinks, any of those kinds of things, Notepad's not going to do that for you. But you don't want that, because that would be embedding a bunch of codes into your file that are that the interpreter's not going to understand, and you'll end up with errors that are weird. So stay with a very simple editor like WordPad. Or if you feel like you got to use Word, but save it as a text file. And that'll remove all the formatting content from inside, and it'll just be characters like that. So the great thing is, you can write your program out, say, hello, I'm going to create a print, hello world. You guys are getting tired of seeing me do the same thing, aren't you? You should be. Notice that it also changes colors in there to give you a hint as to what it's seeing. And we're going to do this file, and we're going to save it as we'll just go into for downloads, and we'll just call it temp.py. Okay. And so I want to run it. Okay, I'm going to run the module. And there it is. See, it runs the file, and then it shows up in the shell here as to what the results would be. So anyway, that's it. That's, the rest of it is for you to explore and learn a little bit about. But I wanted to give you another option. It is very simple, and it's convenient to be at the operating system. I'm not a Mac OS user. I don't have an Apple machine to show it to you. But at the end of the day, I'm sure you can figure out, what happens next. So, all right, next slide. So, we're going to talk about values, types, and variables. We've already mentioned this before, but we need to be distinct between what these three things mean. So values are values. They're what you think of. They're the numbers, they're the letters, they're the whatever. So the example here, 1, 2, and 3.14 are values. This is the real world stuff. Right? But to get them into a computer, we have to specify type. And I talked about that in the previous one. The type specifies how big, how much storage area is how much memory is needed to store something of that type. So, for instance, it takes more storage to store a string than it does to store a character, and that makes sense. However, when we get to some of these others here in a moment, we're going to find there are surprises, and I'm not going to get into how big is it or anything. That is stuff that you would learn later on. You'd have to learn how big is an integer, how big is a floating point, how big is a Boolean. All of those kinds of things are things that we learn later on, because they are important to understand, because not everything is done in Python, and it's not all that simple. Python tries to make these things simple for you because it was kind of written for people kind of like yourselves, people that are kind of on the fence. They don't know if they want to be the hardcore programmer or not. So, One of the nice things that you can do is, and I guess I should have left idle up, so let me pull that up, is I'm not going to demo everything because frankly there's a ton of stuff here. The original slide deck had 20 slides in it. I think I knocked this down to 17 because we covered things in this original slide deck that we're not going to be using for the first program. So in interest of trying to keep this shorter for you, keep your attention, and tell you exactly what you need, and not to overwhelm you, because there's a lot here, and I recognize that. So I'm trying to keep it to just the basic things you need to know, and then I'll add some more during the coming weeks so that you have everything that you need to do the programs that are coming up, because the second or third program are going to be more complex than the first. Third will be more complex than the second, as you might think. But none of them are what I would consider complex programs by any stretch. So, but I'm trying to make sure that I don't overwhelm you, because I've seen this several times now where people they kind of freak out after a while because there's so much. So we're not going to do that this time around. We're going to try not to anyway. So, no, I'm going to resist it. I want to show off and bring up the idle and if it looks like at the end we've got some time, I'll demo some stuff in the idle IDE, but for the time being, let's just try to follow along here what's going on. So again, there are lots of types. So there's 4 that are listed. Int stands for integer. When you're referring to the type in the program, and you might have to, and you will for sure, you have to specify the type. You don't type out integer, you type int. Okay, same thing. Float stands for floating point. Floating point is what you would think of as decimal. If you have a decimal point in there, it's a floating point. This is necessary to distinguish between the two, and it's going to be very important that you keep those two things straight, even in the first program. So I'm going to kind of re-emphasize this over and over and over. Integer is a number without a decimal point, or it's what you might consider a whole number. It could be negative or positive, but it cannot have a fractional part to it. And one of the things I discovered when I first started teaching this class was that many of you, and it makes sense once I thought about it a bit, many of you do not have a lot of experience with integer mathematics beyond addition, subtraction, and multiplication. But when it gets to division, the classic way that we used to do integer division isn't taught any longer, as I understand. Talked to one of my daughters as a teacher, and she said, no, we don't teach that. Anyway, however, it's still very important as far as computers are concerned, number one, to be able to represent something as an integer versus float, the floating point decimal, and in particular, decimal division does an entirely different thing than, not decimal division, integer division does it entirely different than decimal division. So if the only thing you've ever learned is decimal division, this is going to be new. To me, it's old. And in fact, there is another tutorial coming up, it's in this week, that I'm going to walk through how integer division is done by hand so that you can practice them. And there's going to be some homework on that. So this is how important it is. To be completely transparent, without understanding integer division, you cannot do well on the first program. It's required. Now, in addition to the fact that it's necessary because there's a machine underneath, it's also very useful. We use integer division to do a lot of things, and I won't get into that any further. So the next thing we see is string. That's what str stands for. And that just means a group of letters. Most commonly, of course, those letters are a word, or maybe they're many words. The thing to understand about a string is sometimes elements of what makes up a string are things that you don't think about. So, for instance, a space is a character, and when you put a space in a string, like the space between hello and world, we have to record a space in there. And so a string is essentially a group of characters that are treated together. They're a holistic group of characters, a word, a sentence, a paragraph, whatever. At the end of the day, that's what a string is. And then Boolean, I'm not sure whether they're teaching Boolean in high school yet or not, and they may or may not, depending on how much mathematics you took in high school. But Boolean is simply it's logical mathematics. It's the mathematics of logic. And it's named after George Boole, a mathematician who kind of came up with that, who first formalized the idea of logic and made it more and made it a mathematical operation instead of simply one that was more almost philosophical before. So these are some of the more critical variable types that you'll use, certainly in this class. There are many, many others, but this is sufficient for what we need to do. Now, as it says, if you have a question about what the type of something is, of value, in this case 3.2 or true, or at least if you're uncertain as to how Python will interpret it, you can do this at the command prompt, at the shell prompt. You can go type 3.2 and you'll get float. Or you can, any other number with a decimal point will give you a float. If you were to simply type in 17, it's going to say it's an integer. And we can kind of see this. We can kind of see this in the second example here. In this case, it's kind of a different type or it's a different approach to the same thing. In this case, we created a variable, and it's kind of like, okay, what variable is this type? And the actual syntax that the shell will throw out is slightly different now. Again, I'm really tempted to pull up idle and show it here, but I'm so concerned about this taking too long. And then this last statement here is important to understand. Variable names can be anything except a reserved word, and we'll see that in a moment, or a name that does not conform with the rules. And the rules are this: it must always start with the letter, followed by zero or more letters, digits, or the underbar or underline symbol. Now, what does that mean? It means you can't have a space. You can't use a special character like the pound symbol or anything else in your variable name. You can, there's another thing too, if you're watching, by 0 or more letters, so you can have a single letter variable, X, Y, Z. And in fact, those are used pretty commonly, X, Y, and Z. However, we'll get to this a little bit more later. That is not recommended. What I'm going to tell you is you want to create meaningful variable names. The reason is that if you're, for one thing, when you write, particularly when you're writing professionally, you're writing for two audiences. One of them, three, if you will. One of them is the machine, clearly, the underlying machine. One of them is for yourself, because you may not complete it, and you need to be able to come back and pick it up and everything else, so you need to be able to read it. And in a commercial environment, what you write, you may go on to bigger, greener pastures, another project, another company, you may retire, whatever happens, but you may not be there. And so it is good practice, it's considered great practice in software engineering to make sure that your variables are meaningful. They express what it is you're trying to represent by storing whatever you're storing. And again, there'll be more examples of that as we go along. And I can guarantee you that if you start throwing a bunch of meaningless variable names out there, I'm going to call you on it and it's going to cost you. So one should use meaningful variable names. They don't have to be sentences, but they need to be need to be meaningful. The name needs to mean something. Now I said sometimes people use X, Y, and Z, but in general we use them pretty much for only one thing. And we won't get into that right at present time, but we use them for counters. So it's not uncommon, say, for instance, to be X to be a counter to count the number of times we do something. And same thing with Y and Z. Sometimes, sometimes you may want to be, you may want to be traversing 3 dimensions in the computer. And so you need X, Y, and Z to give you the coordinates of where you happen to be. Those things are okay and understood. But beyond that, no. In general, the expectation is that your variable name is going to be readable. It's going to make sense. Now, looking down here, I'm going to ask a question. If we were in class, I would undoubtedly ask the question, wait for someone to raise their hand, and if they didn't, I'd call on somebody. Because I'm that kind of teacher. Yes, I do that. Unfortunately for me, not for you perhaps, if you're shy people, I'm not going to be able to do that. So I'm going to pause to allow you to reflect on what you would say, and then you'll understand. And then when I give you the answer, you'll be able to pat yourself on the back, or you won't be able to pat yourself on the back. Regardless. So down here we show, what this last thing is showing, that if you were to use a variable name called more followed by the @ symbol and assign 1,000, the number 1,000 to it, it says it would give you an error. But what error would it give you, and why would it give you an error? What kind of error would it give you? This is where I wish I had the Jeopardy theme going on behind. While you wait. Okay, that's enough. The error is simply that it's an invalid variable name. Remember, we said that it could be letters, numbers. It's got to start with a letter, and it does. It can have any number of letters or digits or the underbar character. And they allow the underbar character because sometimes you need to have 2 words, or maybe even 3, to have a meaningful variable name, and you can write them all together as one big thing, but it's harder to read, so we put the underbar in there to allow you to simulate a space. You cannot put a space in a variable name, because that will throw it off every time. So, that's it. We're going to move on. Quickly, reserved words. I'm not going to read these, but you cannot use a reserved word as a variable name. You can't. It will cause an error. It'll be problematic. However, there is one thing I will point out too that this reminds me of is that Python is case sensitive. That means print is not, little p, little r, little I, little n, little t is not the same as capital Print. They're not the same. And so if you were to, first of all, you couldn't declare the little one as a variable. You could declare with capital Print, could declare that variable. I wouldn't necessarily suggest it unless it was part of a multi-word variable name, because that would just cause some confusion, not much, but it would cause some. But all of these variables, all of these names mean something very specific within the Python programming language, and so you cannot use them as variable names. There are others. I'll leave it, your interpreter will tell you when you do it. There's better lists somewhere, but this is good enough to give you an idea of what they are. There's not thousands of them, but there's more than we listed there. Now, further organizing what goes, how we look at a program. So a statement is a unit of code, a complete enough unit of code that the interpreter can execute it, and if there is a result from that, it will show that result. So okay, so I'm going to leave that there. I'm going to go on to the next one, and then I'll kind of return. So several statements are a script, and I thought that very telling. It's very telling to me that they name that a script. In general, scripts are almost not programs. They are and they're not. Scripts kind of are baby brothers to programs, if you will, or baby sisters. Not being gender specific or anything. They're for doing something quick and dirty, but not necessarily for the commercial world, so to speak. And again, I kind of hinted earlier that that there are advantages and disadvantages between interpreters and compilers. And if you watch the animation, it does a pretty good job at getting to the basics of what's the advantages and disadvantages. But anyway, so you got a script. We've been calling it a program. So you write a bunch of lines in a text file and then you run them at the interpreter. That is what we're calling a script here. Honestly, I don't care which term you use. Doesn't make any difference to me. You can call it a program, call it a script, but I thought it was interesting and telling when I read that. So in this case, so several statements in a row. So I've talked about that in the past, when I talked about the 3 things that every program must do: input, process, output, remember? In this case, notice that there is no real input here. We're not getting anything from the outside. There is input nominally, in that if you look at 1 and 2, those are input, but they're not input from outside the program. And honestly, without being able to bring information in from outside of the program, not very helpful. It's not very useful, and you kind of like, well, but where we're at, this is fine to learn the basics of it. And so notice that these statements, the statements together produce an output. And essentially what happens is, if you were to put a file in there that had these statements in there, if you put a file into the interpreter, it would start at the top and execute each in sequence from top to bottom, and the output would look like that. And what does this say? It says, okay, print the character 1. I'm very specific about that. That's character. And then the second one is assign the value, entirely different thing, assign the value 2 to the memory location named X. And the third one says, print the value that is in the memory location, X. And you see the output, and hopefully you understand, you should understand why that is. Operators are symbols that represent operations, addition, multiplication, etc. The things that they operate on, whether they're variables or literals or whatever, what they operate on are called operands. So if both operands are integers, in Python 2.7, this is a little history, kind of really not useful, but it does kind of, I'm not sure I even want to spend time on this one, but so first of all, remember automatic typing. So if we assign the value 59 to the variable called minutes, if we put that in minutes will be automatically typed as an integer. um, in this case, and see, this is out of order. Okay, this is kind of talking a little bit about it. So this gets to be very important. This is why I've highlighted it. So integer division. Let's take a moment. An integer division. Let's talk about decimal division. So what is, I'm trying to think, 10 divided by 4? 10 divided by 4 is 2.5, correct? In regular division. That's decimal division. If you were to type 10 divided by 2 in a calculator, it would come back and say 2.5, and you're probably very familiar with how to go about doing that. The actual process you use to do is probably different than mine because, again, I'm not a young person any longer, and we learned things differently in those days. But in integer division, what the answer to that would be 10 divided by integer division, 10 integer division by 4 would be 2 remainder 5. Let me think about that. Yes. 2 remainder 5. Yeah. No, sorry. 2 remainder 2. 2 remainder 2. So you see, I was making the mistake of trying to make it fit with the integer division, but it doesn't. And so 10 remainder 2. So 10 divided by 4 would be 10 divided by 4 would be 2 remainder 2. How does that happen? Well, 2 times 4 is 8. You take 8 away from 10. There's still 2 that's not accounted for. And that is set out there as a remainder. So you've seen a little bit of that. Actually, come to think of it, you've already seen some of this integer division. You've seen the results of integer division in one of the conversion processes that we use. If we're, remember converting a decimal number to binary, one of the methods we showed was divide and set the remainder off somewhere else, right? Of course, in binary to decimal division or conversion, each of those divisions will always result in either a 1 or a 0. But in classic integer division, where you're dealing with numbers in the power of 10, you can have any number of different variables or any number of different remainders. So, all right. So the reason that the answer is 0 here is that in Python 2.7 and before, if minutes is 59 and 59 is divided by 60, well, there's an answer that comes out in decimal. I don't know what it is. I mean, I could calculate it, but I don't want to spend the time to do it. But it would be 0 point something, 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 something. But in Python, doing integer division, all it does is concentrate on the whole number part. In other words, the part to the left of the decimal point. And as I said, it would be 0 dot something, 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 and all it's going to return is the 0. In Python, what it's going to do is the way to do integer you don't have that implicit integer division that happens. So you would say integer division. So if you were to express this in 3.0 and later, as if you were to do the same sequence, it will go ahead and do an integer division, and it would do 0 remainder 1. Okay, so you would still get a 0 on the integer division //, but it has a companion operator that you can use that says, give me the remainder portion. And in many respects, I would tell you that the modulus operator is probably more important than the integer division, with the exception of it does help you break things out into whole numbers. And I'm not certain if it's still this way, but one of the hardest classes I took in my master's degree long ago was graphics. And that's because at the time, graphic processors relied on converting floating point numbers to integers, because integer arithmetic is faster. However, nowadays, most computers have dedicated graphic processors on board that do that kind of mathematics for you much easier, and it offboards it from it takes that off to the side and it does its thing without really impacting the central processor, so to speak. So, but that was one of the hardest classes I had was because so often what we were doing was, you're dividing something in an area or something to figure out where the next point is that you're going to print, and you couldn't, we weren't allowed to actually use a decimal number as a result. We had to convert it to integer, and we had to learn all of the mathematics behind it, and I struggled with that. Just, basically, I managed to eke out a C barely. And that was the hardest class I had. And I worked my butt off. And frankly, I think the C was probably a gift. Only because the instructor at the time, and I won't give you their names, but the instructor at the time probably took pity on me because, number one, it was very obvious I was working extremely hard. And number two, I did all of the programs. I did all of them. I got them all completed, and they were good. And I have plenty of stories about that. At some point, there were so many things I learned from that, and a lot of them were pretty catastrophic. And I didn't sleep a lot that semester. Let's put it that way. Anyway, now I've got this highlighted. I've spent a lot of time on this. This is going to be critical. Everyone understand this. It's going to be critical to do program number 1. You've got to understand this. That's why I spend so much time on it. You have to understand it. It is important in and of itself. It doesn't necessarily have to be so important, but you will have to do it. I guarantee that both of these operators will appear in your first program, or you are not going to score very well. So, if you have questions, if you get confused after having seen this tutorial and having done the homework and everything else, if you're still having problems, you need to get with me. And we'll see what we can do about working it out. But you got to know that. Next, expression. This is not much different, really, than mathematics, to tell you the truth. Values, operands, and operators. And again, it shows that if we were to go into idle and we were type 1 plus 1, it would just say 2. Notice we don't have an assignment in there. We're not really doing anything. Now, the order of operations is mentioned, and then it says PEMDAS. And actually, I had never heard that acronym until I started teaching this class. But PEMDAS just stands for parentheses, exponentiation, multiplication, division, addition, subtraction. So from left to right, it's telling you the order. The first things you do are the things in the parentheses. The next thing you do is any exponentiation. The third thing is any multiplication, then division, then addition, then subtraction. Now, in reality, multiplication, division, addition, and subtraction, it could be PEDMAS, if you wish, PEDMAS, because mathematically, whether you do division first or multiplication first doesn't make a difference. But at the end of the day, this is the order of operations. Stay with it. But when you have expressions, the thing is that you can simply order the operation. You can order the operands in such a way that you don't need parentheses necessarily, and you would rely on the order of operations where your exponentiations would happen to the leftish kind of thing, and then your multiplications, then your divisions, then your additions, subtractions. You could theoretically do that in some cases, but the reality of it is use parentheses. It's just a lot easier. It tells everyone what's going on. So it's easier for other people to read. Remember the three things that I told you about that you're writing for. You're writing for the machine, you're writing for yourself, and you're writing for the program that comes on behind you. So comments. I've moved this up. This is, again, very important, too. This goes back to very similar kind of thought process to when I was telling you about using meaningful variable names. Sometimes you just need to, it's very helpful to just put a line in there that says, hey, I'm doing this kind of thing, and this is why. So at various times in my career, we had comment templates that we would have to put before procedures and this and that and the other thing. So that we made sure that for programmers coming on behind us that they would have information that they needed to know to understand what a procedure or a function did and why. So comments are not executed. So comments allow you to write information in there that's useful for you or the programmer that takes over to understand what's going on, to explain what happens, and essentially all that's required is to put the pound sign in front of it. Compute the percentage of the error that has elapsed. I'm not sure why that's in there. My bad. Sorry, folks. I think that actually probably has to do with casting. Ignore that for now. I probably won't edit it, but ignore it. Don't do this down. What does it say? So why v is assigned the value of 5. And, why is it saying don't do this? Is it because the comment's placed incorrectly? No. You can put a comment anywhere. I would be careful one of the things you need to understand, though, is when the comment character appears, everything to the right on that line will not be read by the interpreter. So, you wouldn't want to put the comment in front of v equals 5. You could put it in the line before, because essentially that's what happens when it sees the comment character. It doesn't send it on to be converted. It doesn't send any of the characters following the comment character until it sees the end of the line. When the end of the line comes up, then it goes back and it starts interpreting. So what it's really talking about, and again, this goes back to meaningful variable names. I will have to fix this at some point. But meaningful variable names, so V is not a good variable name. What does it mean? And, okay, if you have a simple program and that's the only place you use it, you probably remember what V stands for. Maybe it stands for velocity. I don't know, but if there's only one. But the truth of the matter is that if you have a bunch of these, you can very quickly get lost. So again, meaningful variable names. That's what it's trying to say. It's much better. Oh, it does say velocity, right? So anyway, meaningful variable names. That's what this is all about. And the comments, you will be required to put comments in your program. That's a little aside here. Read the instructions closely. My suggestion is read them closely, do your program, then go back and read them again and compare it to the program. Make sure you get all of the points in there. Because everything that it says to do in there, it'll say things like you need to put in comments and you need to do this, that, and the other thing. Everything it says in there, if you don't do it, it's points off. And all the time I see people that write really, really good programs, but they forgot to do something. Or I was just grading someone's some of the quizzes that you submitted, and some people, I said provide 2 examples, and some people only provided 1. And it's very clear in the instruction says 2, 1 of this type, 1 of this type, and they only provided 1. So they got half the points they should have got. So try to develop these habits. As I also said, the world of computers is about precision, and it's all very, very specified. There's not room to be flighty, because you're dealing with a machine. A machine will not interpret. I don't care what they say about AI. The AI that would interpret that, oh, he really means this v is velocity and everything's okay. That doesn't exist yet. Maybe it will someday, but it doesn't exist yet. What you see today is not that kind of AI. So, variable names. Casting. Okay, we talked earlier about when we create variables, they have to have a type, even though you aren't necessarily very specifying them. And in most languages I've used, you have to specify what type the variable is. You usually declare the variable at the beginning of the code segment you're working on, and you specify the variable name and the type, and perhaps assign an initial value to it. It's not always required. But in Python, you can just create a variable name, just write a name of something, and then assign a value to it. And behind the scenes, Python will say, hey, that looks like an integer to me, so it'll create an int type. And we've already been through that. However, sometimes you have to be very, very clear about, sometimes you can have a value of a type that you actually need to do something. You need to treat it as if it's a value of another type. And it's, again, this is very critical for your first programs, for your programs. We will, in the, shortly, trying to remember, yes, in this tutorial, we'll be talking about input. So far, one of the things I've said several times is the programs we've done aren't particularly useful, because all we're doing is manipulating literals, and literals exist within the program and only within the program. But if you think about the programs you do all day, what do? They take input from you, right? From the user. Or they take input from another program, or they take input from another, whatever. But they're taking input, and the whole idea is we're writing things, we're writing programs that can take information, that somewhat arbitrary information that we don't know the exact value, but we know the type of the value, we know what it represents, we know a lot of things about it, so we can write programs that manipulate it, even though we won't know the actual value until what we call runtime, until it's actually encountered. And so shortly we're going to learn a way that we can get information from a user. And the challenge there is that particular function that we're going to use automatically assumes it's going to get a string. However, if we're asking for a number to be put in and we want to do some kind of mathematics on that number, strings, you can't multiply a string. You can't, I've got a sentence, I want to multiply it by 2. Does that make sense? Does that mean I should have 2 of the same sentence? Or what does that mean? It doesn't mean anything, right? In the real world, you wouldn't multiply a sentence. The closest to dividing a sentence might be that you're going to break it into 2 pieces. And those things exist. It's possible to do those things, and I don't think we actually get into it. But and it's not hard. There's built-in functions that make it very easy, but you've got to make it very distinct that when you are when you know that the number, when what's coming in is a number that you're going to want to do some mathematics with later on, you've got to be able to convert that to a numeric type, whether it's float or integer, so that you can do the mathematics. Because if you don't do that conversion, what will happen is when it comes in, it'll automatically be assigned a string type, and then when you go to do your whatever calculation you're going to do with that number, you're going to get an error. It's going to come back and say, no, I can't divide a string. It's a string. What are you doing? Wake up, bucko. I can't divide a string. What are you talking about? So, but the reality is, say you enter in 20, the character 20, at the keyboard. It comes in as a string, and you want to divide 20 by 4, it would fail. All right. So we have something that we call casting. And this is a common term that's used for a conversion from one type to another. And it's essentially all that happens is we use the type name and then we have parentheses that we can include a variable, a string, the output of an input function, any number of things. We can put any number of things in here that are not integers, and it will attempt to convert it to an integer if that makes sense. Now, if you were to put in, int, and then Ted in quotes, it would cough a hairball. It wouldn't like that at all, because how did you convert Ted to a number? It's not a number, right? But if you had a string that was 20 and you wanted to treat it as 20, you could do that by putting that variable with 20 in it within the parentheses followed by int. We're going to show you examples of that. There's going to be plenty of examples of that. And again, this is another thing you're going to have to do. Float does the same thing, except instead of integers, it's going to be doing floats. String, again, you can convert any number of things, almost anything, to tell you the truth. You can convert to a string. And then and that becomes necessary. So kind of the reverse is true. When you go to print something, which you've seen that command, when you go to print, it assumes it's being given a string. Now, if you've done an integer calculation and the results in a variable, then you have to convert that integer variable back to a string in order to print it. And you use casting to do that. So you would do str and then your integer variable inside the parentheses. All right, two types of casting, as it says, automatically performs implicit type conversion, but explicit casting, which is what I've been talking about, is when we type in that we want it to treat it as something else. We want this variable to be treated as something else. All right, so here's an example. The num's assigned the value of 5 because it's looks like an integer. The integer will automatically make it an integer, and it said print type the num. Now remember, this is something we saw already. This is saying, okay, what is the value of the num? And it comes back here, and you see that the result would be class is int, and that the value is 5. Okay, well that is implicit casting. But let's say that we wanted it. Okay, we go to. But what isn't obvious here is. Okay, well, implicit casting. Let me think about this for just a moment. Yeah, I'm not sure this would work exactly the way it's saying here, but what it's saying is it would recognize that, okay, because you know that the type is integer because you asked for it, that you're going to I'm going to treat this as a string. I'm going to go ahead and do a conversion of the integer to a string in order to print it. I would prefer to see something along an actual explicit type, explicit casting. So notice here the difference. Same thing. In this case, we know that what is in the num, this is continuing on from here, the num is 5. It says to treat that as a float and put that in another, and replace the num. So what this does is it changes the num to the float type, and then it prints the value and then the number. Notice though that the difference is that the output, since it is floating, even though the actual value hasn't changed, it's going to represent it as a decimal, 5.0. All right, Booleans. I talked a little bit about this, but Boolean arithmetic is very important. As you know, zeros and ones, right? On or off, true or false. All is represented, can be represented in that manner. In fact, it says in here later on, I believe, or, oh yeah, it says right there, zero is interpreted as false. Any non-zero number is interpreted as true. Now, that can cause a lot of trouble sometimes, so you've got to keep that in mind, that zero is equivalent to false. Any non-zero number is true. So, the important thing more than anything else is to explicitly set it so that you know that it is true or false. And in general, what you want to do is you want to assign, if you want it to be true, you assign the value 1 to it. Or there's actually I believe there's, or you can assign it the value true, in which case it will put a non-zero number in the memory location, but it's going to be 1. But you can have a result where a variable ends up, through other processing, being a non-zero number that is not 1. So that's why the rule is any non-zero number is treated as true. Boolean logic is very, very important to what we do. It's not that hard to understand the basics of it. There's not that many things to do in there. But the theory that seems to be borne out in practice is any complex operation can be expressed as a series of decisions that go one way or the other based on any number of parameters. And so we have these ways of comparing values, and we've alluded to this before. You notice the first thing we see here is 2 equal signs in a row. That is your equality sign. So if we're going to do something, if variable x is equal to 10, we would say x equal 10. And it's important for you to remember this and keep it in mind, and you will make the mistake at some time. Do not get equal confused with a single equal. It's a very, very common mistake people make. And that is that, and why is that? Because what's a single equal? Anybody? Bueller? Anybody? A single equal sign means a sign. The result of an assignment is true. It was successful. So if you assign a value to a variable, behind the scenes, it returns the value true. And so if you use an assignment operator instead of an equality when you're checking something, it will always evaluate to true. And that is a very, very common error, extremely common. I would say you're all going to do it at least once. And it's going to drive you crazy because you can't figure out why the program isn't working right. And eventually you will realize, well, wait a minute, that's supposed to be a equal because I'm checking for the I'm checking whether a value is truly equal to something, a constant or some other value or whatever. But at the end of the day, that's very, very important. So, equal is the equality, is true equality within Python, and in fact, every C derivative language that I'm familiar with. But that is the equivalence operator, if you will. And then when you see the exclamation point equal, and if you hear me say bang equal, that's just old Unix ways of saying that. Exclamation point equal means not equal. And then we got greater than, less than. You should be familiar with that. You've got, less than, greater than. Then you've got less than or equal to. And then you've got greater than or equal to. And then you've got is and is not. Okay, so the three logical operators, and this is, when I teach architecture and stuff, that's generally where I begin, an or a not. So, and this is absolutely critical the way computers work. They would not work without this ability to make these decisions based on logic, and they all use these three operations. And they're all implemented way down level, little tiny transistors. A few tiny transistors is an AND gate, an OR gate, or a NOT gate. And anyway, so you begin to have some logical operations. So not true is false. What's the not means essentially the opposite. If it's not, well, it's the opposite. So anyway, the logical operations of a computer uses all these symbols, and we will use them shortly when we start evaluating different things and making actions based on what they are. Those decision properties, if you will, Boolean is all about making decisions, and a computer has to. If a computer program has to, rather. If this kind of situation happens, then we do this. But if it doesn't, then we do that. Or the other thing. Or if it doesn't happen, we do this. On and on and on. And so Boolean expressions become very important as well. And they can be changed. And very, very complex. I used to teach a class many years ago called Basic and Advanced Digital Techniques, where I use something called the De Morgan's theorem, because we would start with these very, very complex Boolean expressions and simplify them with De Morgan's theorem. Input. Okay, you guys are somewhat familiar with this. You've seen it. There's a couple things you see in here that's a little bit different from what you've seen before. But first of all, first thing you got to remember is, as I said before, by default, what you're going to get from the input function is what is returned from that function is a string. And this will be important because if you say, how old are you? Because you're trying to figure out if they're old enough to do whatever, and you want that number, you want to be able to treat that number as a number. Is that number, the number that was entered, is that number greater than 18? Is it greater than 21? Is it greater than 25? Those are the kinds of things you need to do. So you would have to convert what comes in here. You have to convert it to, so by default, what means name is going to be here, by default, it's going to be a string, simply because the input operation is going to output a string. It's going to be string. Unless you do something like we see down here. It says how fast are you going? That's a number. We know that. We don't express numbers as a string. And at some point, I'll probably get off and tell you why all of this, why there's a difference, why the computer can't tell the difference between them. But at the end of the day, we see in this case, we're going to want to be able to treat this as a number. So what do? we cast the result of the input function using the int cast that we talked about earlier. We say, okay, do this inside the parentheses, execute the input command. That's going to show up on the screen. The user will type something in. That'll be returned as a string, but then cast to an integer, which means that the variable speed becomes an integer speed. Now, one of the things that can happen, though, is, and this becomes something that needs to be thought about when you get probably more advanced. I don't worry too much about this, but this is a perfect place for an error. This is a perfect place for a user to create an error. What if I say, how old are you? And someone types in FOURTY -THREE 43. That is not a number. That's a string. And that would cause this statement to crash. It would crash your program. So later, very briefly, when you get to be a more advanced programmer, you learn that you have to do what's called error handling here. You have to recognize that it's a rule of thumb. If it's kind of like Murphy's Law, right? If anything can go wrong, it will. And it's really the same thing. If it's possible for a user to screw up the input, they will. This is why, WYSIWYGs and radio buttons and checkboxes are so good, because if, you got a checkbox, yes or no, right? Or you got a radio button, it's yes or no. You can select yes, or you can select no. It doesn't give the user the opportunity to type in maybe, or to fat finger it and just YE instead of YES. Again, computers need very precise input in order to make these decisions. So what you've got to do is you've got to work around the idea is the expectation that users they'll put the wrong thing in. They're going to make a mistake, and you need to be able to handle it gracefully so your program just doesn't crash and burn. We're not going to get into that in this class, but if you get into programming, you'll learn techniques of error handling as well. And input, so input always returns a string. I already talked about that. And we're going to get a type error because it can't, in this case, you enter a number, enter a number, and it comes in as 5. Now it's a string, right? And then we try to add it, and it's going to come back and say, I can't do that. I can't add 5 to a string. In reality, that's kind of a concatenation function. We have the ability to put two strings together. Say you had 2 words that came in and you wanted a space between them. You could concatenate the first word, a space, and the second word. And again, that's one of the things that I'll be looking at is that, are you attempting to format correctly? If your output puts words together because you didn't put a string in there or a space in there, that's going to be a problem. And how do you do that? Well, you have to learn these techniques, and we'll get into that in some examples later on. So again, notice that if you print the type mynum, it's going to come back and say it's the class string. So you can't add 5 to a string. You can't add the number 5 to a string. So it's looking at this and it sees 5. It sees the value 5. In the memory location, what does it see? It sees a bunch of zeros, then 101. And that's what it sees. And that's so it says it's a number. All right? And then on the other hand, we got a whole bunch of ones and zeros that represent a string called mynum that underneath it represents the character C, which is not the same as the number, the character 5, not the same as the number 5. Character 5 is not the same as the number 5, and I'll get to that later on. But anyway, so not to belabor this any longer, you know, managing, even though Python does a good job at managing type, you have to be aware of it and you have to take it into account. So output, there's lots of different places you might put output. Screen, you've seen. All right, it's print. Right? That's your print command. However, you might want to print to a file. You might want to save things to a file. That's something that goes to a hard drive, or maybe a thumb drive, or maybe even old tape, or something along those lines. You might want to actually send the output to a printer, or maybe you want to send it in a packet to someone else across the network in some form or fashion. These are all possibilities, and there's probably many more that I'm just not thinking of. But for this class, we're only going to be doing print to screen, so that's the only one you have to really worry about. But again, what did we really talk about in here? We've talked about input. We kind of talked about input at the end. We spent the first part talking about the whole process stuff, and at the end we talked a little bit about input, and then we talked a little bit about output. But that's the relative, you know, to be honest, most of your effort is going to be in process. Input and output are pretty straightforward. Once you kind of learn the ways you do those things, then you're not going to spend a lot of time worrying about it again. But in process is where the meat of where your work is. So, what did we do? Idle development environment, we looked at that. Values, types, variables, expression, reserved words, statements, operators. You've seen all of these things. Remember the things that I emphasized, study them, you know, get on top of this. How do you do casting? Make sure that you understand integer division really well, because it's going to be necessary in your first program. You may think you can come up with other solutions, but when it's there, the only valid solution is going to be the integer arithmetic things, because that's what we want you to use. So with that, I'll leave you at this. I know this is a ton to consume, and hopefully this, along with all of the other material, will guide you through this. You know, take the time, folks. You know, particularly those of you who've never programmed before, spend some time, look through the notes. Hopefully you took some notes while we were doing this, because, you know, I've been very clear. I've tried to be very transparent about not only the things you need to know, but what you need to know for this program, to do the program, your first program. So, and as always, when you get around to writing that first program, if you have troubles, who do you reach out to? Me, and me alone, no one else. All right, everyone have a great one. We'll talk to you later.